Good evening to all of you. First of all, I would like to thank the organizers, in particular Dr. Professor Ishwar Prasad for inviting me and uh, tell you about few of the things what we have done on both Delhi Iron Pillar and Kudichadri Iron Pillar. I'll try to be brief and then I will try to explain the work what we have done. In one case, we demonstrate that the pillar is made in the horizontal fashion, and also the interlocking of the lumps, which are made in small quantities. Sometime back it was told 5 to 6 kg, but we believe that this may be around 20 kgs in the case of Delhi Iron Pillar. And also we also take that the locking mechanism also is taken from the natural rock structures. So this is one aspect which we would like to bring out. And also in the Delhi Iron Pillar, we feel that there is gold at one of the regions. That also I will show you that how we have interpreted this. And also the thermomechanical processing, it would have gone through at different regions, and the structures what you see through in situ metallography, that also indicates that the temperatures and strains and the cooling rates, in addition to the composition variation from place to place, would have played significant role with respect to the microstructures those are generated. But at the same time, I would like to say that the corrosion resistance might not be having to do much with the microstructures rather than the phosphorus. And one more point we would like to bring out is that the many of the people interpreted on the samples that the needle-like structure what they see, they consider as phosphorus related. But we also, this is an indirect evidence, not direct evidence, that these are cementite needles. Okay, so with that I will start my presentation. Okay, this is a Delhi Iron Pillar. So we use number of investigations. These include visual inspection, dimensional measurement, X-ray fluorescence, in situ metallography, in situ hardness, ultrasonic and impact non-destructive testing, and the gamma radiography. And particularly the gamma radiography has been done in the night because of the hazards involved, and also to see that the visitors are not affected by these investigations. Now, if you see that the microstructures, what you see in different places, so here the height wise and then the location wise, it is given where the microstructures have been taken. But more importantly, if you see that Bastar, where the iron is also made, you can see that the Adivasi iron is the Bastar iron, and the Delhi Iron Pillar microstructure is shown on the right top. And here you see a modern ferritic stainless steel, where from the electron microscopy you can identify the possible orientations of the cementite. And if you align the grains in a particular orientation, there would be a one-to-one correlation about the cementite, which is identified through electron microscope of the modern steel in the ferrite matrix, and the orientations would exactly match. So from the orientation relations, so this is the indirect evidence, what I was talking. So it is cementite and not related to the phosphorus. But phosphorus is more uniformly distributed, we believe, in the matrix, and that is giving the corrosion resistance. And if I arrange these microstructures in a particular fashion, notwithstanding the location and locations, you can see that when we go from left to right, so there is a increasing temperature and slow cooling rate for the corresponding microstructures. You can see the continuous variation in the different types of microstructures what are obtained depending on the temperature, cooling rate, strains, how much strains it is given, that is how much hammering is done. So that means there is quite a bit of variation without much robustness of the process, because they won't have the much knowledge, but it is more integrating it without any difficulty. And I think one of it is shown, the horizontal one is shown by um, Dr. Professor O.N. Mohanty. And there are two schools of thought whether it is made in horizontal or vertical fashion. And we would say that it is done through the horizontal fashion. That is essentially because when you do the hammering on the horizontal fashion, so you will see the interfaces in the circumferential axial orientation. Whereas if you do the pillar in this fashion, all the interfaces between the lumps would be in the radial circumferential direction. So what is done is that when you do the radiography, you can see that the orientations of the interface, this is in the axial direction of the pillar, you see that these are all axial and then circumferentially oriented. So if the interface is not like that, you won't see the contrast from the radiography. That is one aspect. And then in one of the regions of the iron pillar, you can see that the white contrast in the radiograph means the metal is heavy compared to the remaining regions. And that's why X-rays are absorbed in that region, because X-ray absorption is directly related to the atomic weight. So we believe that there is some material which is denser than the iron. Only that much we can tell. But further, it is only a guesswork that it is silver or gold. So normally, gold is used in many places. So it is in the even bronzes, etc. So we believe that it is gold which is there inside the iron pillar. If it is a void or something, means you will see dark. So that is another point which I would like to say. Third is that locking of the lumps. When we see this orientation, it's only I am showing it pictorially as one image, but there are number of radiographs. Invariably, in every radiograph, you can see that the locking mechanism of the one lump to the other, the shapes are similar to the way we see these rock structures, natural rock structures. So that is another point which we would like to say, that they have taken the nature as the basis so that it is becoming more stable. Whereas in the case of Dhar pillar, most likely they would not have followed. You can also see that horizontal, more plate-like things. So that is the way the Dhar pillar would have broken. But so see, there are certain things when I say are direct evidence, there are a few things where we say inference. So that is subjective. But we believe that what we are speaking is more or less true. But that is subjective to different people. And one more point we would like to say is that in the bell region, the top bell region, one portion is cast structure. It is not the solid state reduction process, and this must have been added subsequently. And there is also a hole. So there, I feel that they wanted to fix some idol or some piece, something, but which they have not completed. So that way also it is an incomplete thing. So these are some of the points which we have brought out from our study. So in essence, that at least we could bring out a few points from these investigations, and some of the unresolved points have been brought out. So that is with respect to that. And this is the Kodachadri iron pillar. I think already the information is already given with respect to this pillar about dimensions, etc. This cross section is relatively small, and we have taken some studies here also from different portions. And then if you see, the corrosion rate varies from bottom to top. In the top region, the corrosion is very high, whereas as you come down, the corrosion rate is low. That is one point. Another is, this pillar is a square cross section, and the pillar which the side which is exposed to the Arabian Sea, the west side, that has the highest corrosion, whereas if you see the face on the eastern side, it's almost very small corrosion. So there is a tremendous difference with respect to the corrosion from the facing and also from the height, because the height is more, means the directly the sea breeze is coming, and then it is having a more corrosion effect. So we have done a lot of work. So this, you can see that in the west region the corrosion is more, and as you come to the opposite direction, particularly the east one, almost very small extent of corrosion. Another thing is, if you see that structure, you can see very clearly the hammering, and then the spread of that forged material which is coming out. So this is also done by forging, but whether it is done horizontally, vertically, that we would not be, I would not be able to tell from the studies what we have done. So here also the microstructure varies quite a bit, and it also has the ferrite and then perlite structures. And here we have also taken a small piece from this pillar because it is too much rusted, and then you can take with from hand itself, some piece would come out. So, and then we did the investigations, we did various elemental analysis and all, and you can see that there are some carbides, that is the cementite, and also we have calcium based slag inclusions, what you can see. So this is again a ferrite perlite structure with slag and also the carbide precipitates, what you can see here. And if you see the hardness variation and the composition of the carbon which we have taken based on the ferrite perlite percentages, the and the expected hardness taking into account certain heat treatment conditions, the hardness of the pillar is more than you can account for the carbon content inferred from the ferrite perlite compositions. So what we believe is that it is in the worked condition. So that's why the hardness is more than what is expected in an annealed ferrite perlite condition. So that is another information what we could obtain. And also if you see the ultrasonic longitudinal velocity which we have measured, because the cross section being small, we are able to use reasonably high frequency, and we obtained good ultrasonic velocity information. So from the ultrasonic velocity information, what we believe is that for the given thickness, we know that standard velocity in steel, the velocity what we are getting is much less. That also accounts for a lot of voids, or the material is not continuous. But we did not do the radiography here because already simple ultrasonics itself has given us the required information, and also we had only certain time limit allowed by the Archaeological Survey of India to carry out these studies. So these are the some of the studies what we have done on the two iron pillars. And since time is short, I try to go through very fast. And thank you very much for your attention.